Can you believe we've already made it to the final section of Chapter 3? Section 3.7 is all about solving equations and problem solving. Before we can begin solving any sort of problems, we need to first of all define the zero product property. The zero product property says that if A and B are real numbers, then this is true. If A times B equals 0, then either A must be 0 or B must be 0. Basically, in order to get 0 as a product, one of the two factors has to be 0. Makes sense, right? We're going to go ahead and use this property quite a bit in solving equations and working with our problem-solving strategies. Let's go ahead and look at our first example. I want you to solve for t in this equation. 3t squared plus 14t minus 5 equals 0. Now the first thing you should think of is, hey, I could use the zero product property. In fact, I already have 0 on one side of the equal sign alone, so as long as I can rewrite the left-hand side as a product, then I can use the zero product property. What did we learn in 3.6? We learned how to factor trinomials into a product of two binomials. Why don't you guys go ahead, use the strategies you learned in section 3.6, and factor the left-hand side of this equation. Pause the video and unpause when you are ready to move on. Hopefully, you got that the left-hand side factors to 3t minus 1 times t plus 5. Now, if we want to use the zero product property, what does it say? It says as long as we have a product of two numbers, one of the numbers must be 0. Therefore, either the factor of 3t minus 1 must be 0 or t plus 5 must be 0. Both of these are just linear equations that you should be able to solve using strategies you learned back in the beginning of UMTYMP. Go ahead, take a second and see if you can find the solution set for this particular problem. Just like usual, unpause the video once you think you have your answer. Hopefully you got that t is equal to positive 1/3 or t would equal negative 5. Remember, you can always write it as a solution set. Negative 5, 1/3 would be our solution set. And again, the proper way to write it would be from least to greatest. Let's check out one more example. This time we'll do a problem-solving example. We're going to go ahead and look at this problem. The lengths of the three sides of a right triangle are represented by consecutive whole numbers. Find the lengths of the three sides. Now remember, you are in an algebra class. You must solve this algebraically. We must define our variables and then use those variables to write an equation and then solve. So what are we even looking for? We are told that we need to find the lengths of the three sides. Let's go ahead and define the lengths of the three sides in terms of a variable. I'm going to go ahead and just use x. Because I know the sides are consecutive whole numbers, I can write them as x, x plus 1, and x plus 2 as the lengths of the three triangle sides. Now, there's one other important term or word in this problem that's going to help us. That's the fact that we're dealing with a right triangle. We know a theorem relating the sides of a right triangle to one another. That's right, the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared. Or really, you're doing the sums of the squares of the legs, which are the two shorter sides, and that must equal the square of the hypotenuse, or the longer side. It would make the most sense that x plus 2 is the longest side, i.e. that's going to be the hypotenuse. Therefore, we can write our equation like this. I then get the equation that x squared plus x plus 1 squared is equal to x plus 2 squared. Again, that's just using the Pythagorean theorem of a squared plus b squared equals c squared. The next thing I'm going to do is I'm going to expand out both the x plus 1 squared and the x plus 2 squared. Remember, If you are multiplying a binomial by itself, you should think of foiling or the distributive property or using that area model. You cannot just distribute the squared in. You have to take into account those middle terms. If you expand both of those, it should look like this. X squared from here plus x squared plus 2x plus 1 from expanding this, and then x squared plus 4x plus 4 from expanding this. Once you get here, go ahead and combine your like terms. In fact, you should automatically be thinking, because you have an x squared, that we should be moving everything to the same side of the equation so that we have equals 0, so we can use that zero product property. Take a second to move things around and combine like terms. Unpause the video when you're ready to check your answer. Hopefully, this is the equation you got. X squared minus 2x minus 3 equals 0. Now you should know what to do. If we have a quadratic on the left-hand side, we should be able to factor it into a product of two binomials and then use that zero product property to solve. Pause the video, factor the trinomial, and then restart the video to check your answer. Hopefully you got that it's going to factor into x minus 3 times x plus 1. Use the zero product property and figure out what x is going to be. In using the zero product property, I saw that either x minus 3 had to be 0 or x plus 1 had to be 0. That leads us to that x would be 3 or x would be negative 1. Now, be careful because we're dealing with a real world situation here. We're dealing with the lengths of a triangle. Can length really be negative? Does this answer even make sense? I don't think so. So because length can't be negative, that means that x equals 3 must be our answer. Now, we need to actually answer the problem. Remember, x was the smallest side of our triangle. Because they're consecutive whole numbers, you would know the other two, or you can plug it into the expressions we had for the other two sides. Your final answer should be that the triangle side lengths must be 3, 4, and 5, which you probably even recognize as a Pythagorean triple. Nice work!